In this lecture, we will take a look at the Terraform taint and untaint command. There would be cases when a resource creation fails when we run Terraform apply. Let's take the same example as before, where we used a local provisioner to store the public IP address of the EC2 instance in a file. However, when we try to apply the changes, the resource creation failed because the path specified in the command of the local exec provisioner is invalid. When this happens and a resource creation fails for any reason, Terraform marks the resource as tainted. And this can be seen when we run the Terraform plan command again. The resource called web server is tainted, and as a result, Terraform will attempt to recreate it during the subsequent apply. In this example, the step that failed was the command executed by the local exec provisioner. The EC2 instance itself was successfully provisioned. In spite of this, Terraform will attempt to recreate the entire resource because it was marked tainted. Now, there would be cases when we want to force a particular resource to be recreated. For example, consider a case where manual changes were made to an AWS instance which is managed by Terraform, such as changing the version of Nginx running on it by manual methods. To revert this, we can either destroy the resource using the command terraform destroy and then run apply again. Or, the better way would be to taint the resource using the terraform taint command like this. When we run terraform plan next, we will see that the resource is set to be recreated. To undo a taint that was applied for a specific resource, use the terraform untaint command like this. This resource will not be recreated now during a subsequent Terraform apply. In this lecture, we will learn how to enable and use debugging in Terraform. When things go wrong in Terraform, the obvious place to look for the cause is in the logs. Although Terraform apply often provides a good indication of what may have caused an error during the provisioning, there may be cases where we need to look a little bit deeper. To do this, we can make use of an environment variable called tf_log and set it to one of the log level values. Terraform offers 5 log levels: info, warning, error, debug, and trace, with trace being the most verbose logging level of them all. When we run Terraform commands after setting the environment variable, we should see a lot of additional logs based on the level that has been set. For example, a simple Terraform plan with logging set to trace would display hundreds and thousands of lines, including those that are run internally by the Terraform plugin in use. These logs are particularly useful when things are not working as expected within Terraform internally. In such cases, the logs generated can also be used to file a bug report with Terraform. To store the logs persistently in a file, use the environment variable called tf_log_path and point it to a file like this. This will ensure that all the logs that are generated are recorded in that file. To disable logging completely, unset the environment variables like this. That's it for this lecture.